In this episode of Hot Hardware's 2.5 Geeks, you have questions about Intel Arc, and we'll have answers next. Welcome back yet again, my brothers and sisters, to a fine episode of Hot Hardware's 2.5 Geeks live stream. Yes, we're live. We're not Memorex, and we haven't been demised yet either. Marco, how you doing, buddy?
I'm good. You took me back to my Radio Shack days with that intro. I used to have to answer the phone. Hi, thanks for calling Radio Shack, where you've got questions and we've got answers. This is Marco speaking. How can I help you?
Oh my God, that's awesome!
Wow. Hey, and
people used to think I was a recording.
You know, and this guy down here in the bottom, he's
hey guys,
not recording either.
I'm live.
He's live. He's mostly live. Although I heard he had a late night last night. So
I did. I was out late last night, but I'm ready. I'm ready. Bring it.
Bring it. Yes, folks. Game face, Tom. So yeah, this in case you don't know the man, this is the illustrious Tom Petersen, Tom Tap Petersen from Intel. He is an Intel fellow, general smart guy, general nice guy, friend of the show, as we were discussing earlier.
Thank you, Dave. Thank you.
He's a friend of the show, and yeah, Tom, welcome to the stream. Good to see you again. It's been a little while.
I'm honestly very excited to be here, and it's great to see both of you. You both look like you're in fine health, so it's a great day.
Yes, we're in fine health and fine spirits when you join us. So, you know, thank you for spending your valuable time with us. We appreciate it. You know, we won't talk about how you were spending time with a lot of other guys around.
I know.
YouTube, you know.
I know. I'm so sorry. I've been bad.
No, you've been good. You've been good. You've been doing your job, as they say, doing your job, and that's
doing
okay.
Doing my part.
That's it. So, yeah. So lots going on with Intel these days, folks. We're going to take your questions. We have a bunch of questions we're going to pepper Tom with. In case folks don't know, Tom is intimately involved with Intel's Arc graphics product line. He is part of the Intel graphics team.
Very intimate.
And
very intimate.
he's all kinds of intimate with the Arc. And yeah, and so that is Arc GPUs are imminent and upon us, and we figured with all of the little demos you guys are doing these days, and the benchmark numbers that are flying around, and all kinds of technology demos, you guys, you know, folks in the audience, you might have a few extra questions rolling around in your head that we can have Tom field and, you know, hopefully put to rest as we lead up to launch, right?
Anything that's on anybody's mind, anything. So have at it.
Have at it. We might not always get answers, right, Marco? But Marco's going to be the bouncer here. So play nice in the chat. Right. And we won't have.
Everybody's being very respectful so far. We're off to a
great
start.
I love it.
Great.
I love it. We
won't have old man or anything like that, or just, you know, all friendly.
Yes. So far, that's good. Yeah. If you're friendly in the chat, we won't have to have the large Italian man from New York show you the exit. If you know what I'm saying. He's up in the top right. Marco. Things are good, and we have a whole menu of litany of questions for Tom. Do we?
I think we do. Between all of the content Intel put out and some of the questions coming in on the chat, I think we will easily burn up this hour. I think we should probably address the elephant in the room first.
If there's an elephant, I want to talk about it. If there's an elephant, let's talk about it.
Whether it's pink or not.
Let's talk about this first, because, you know, there have been rumors swirling that after this launch, next gen Arc cards are canceled. What's the inside Intel scoop on this one?
The inside Intel scoop is I just had dinner last night with Raja Kadori, and as you know, Raja is in charge of AXG, which is the graphics group at Intel, and he works directly for Pat, and I think they talk once in a while. And I can say, after conversations with him directly, that it is extremely unlikely that Battlemage or future GPUs are canceled. As a matter of fact, the bulk of our team is working on Battlemage right now. You know, the silicon takes a long time to build. The architects are busy doing architect things. The software people are, you know, prototyping stuff. Battlemage is making excellent progress. So the rumor that that's canceled is completely false, based on everything that I know and everything that I expect. So that's just facts on the ground. But even if you step back from, facts on the ground, it's illogical, because vector and matrix computing and compute density, getting more bandwidth to the compute engines, is what GPUs are all about. And that GPU structure matches the way workloads are transitioning. So if you look at data center, you look at AI, you look at how all that processing is occurring, that computational problem and solving that computational problem is front and center, very, very important for Intel. And that goes beyond gaming. It goes beyond our client GPUs. It goes all the way up into the server class and data center. And by the way, it also goes to our client. So if you look at our next generation client, GPUs are becoming much more important in the experience that we deliver on PCs. So it's not only false, but it's largely irrational.
Yeah,
And
I totally.
Go ahead, Dave.
Go ahead, Mark. Yeah, I was going to say I think that was the first thought that I had when I heard these rumors swirling around. Like, no way. Intel's got a lot of different accelerators, CPUs. They've got data plane accelerators, lots of different accelerators for AI, and different engines all over the place. You need a GPU. GPUs are here to stay in the architecture, and it would be nuts
until something else that does it better shows up, or workloads dramatically change. But based on everything that I know, I kind of dabble at architecture. I'm a fellow and stuff, and I would say I'm not aware of how this is not going to be the case going forward for this foreseeable future.
Yeah, go for it, Mark. I'm sorry.
No, I say our particular publication, we're enthusiast focused, lots of gaming focus, and you kind of get tunnel vision here. But GPUs are important for Intel's business. Whether or not this exact plan going forward for gaming GPUs plays out is one question, but whether or not Intel has a discrete GPU or some sort of GPU like chip moving forward, they absolutely need it in the lineup. So
there's no question.
This work will not stop. Short term.
And the thing I think people don't really internalize yet is the kind of like the synergy between doing a desktop GPU and everything else. And the reason it's so important to do the desktop GPU is because it gets the most attention. It gets the most banging. That's like, if you can do a desktop GPU, you have arrived. And let me tell you, it is hard. As you guys know, I have a former life. Everybody does. And I've seen how hard this is. And now living through it at Intel, you guys have seen it's been a little bumpy getting this GPU out. And I can say that we've learned so much already. Had we not been doing a discrete GPU, none of this would have been known, and it wouldn't be factored into our next generation Battlemage GPU, which is going to go across the full stack. So it's possible someday that this may not be true, but for right now, no question.
It's interesting if you look at a GPU die architecture, Tom. Maybe you can give us a little bit of insight on this. But if you look at like a GPU die, the physical size of a GPU die on a wafer, right? Mm-hmm. How many die per wafer kind of ratio? It is a large chip. It's a very large hunk of silicon, and so to do that right, and have low enough defect density per wafer and all that stuff is not trivial. Is it fair to say that it's probably the largest structure, one of the largest structures out there versus CPUs, maybe FPGAs? And
when you think about silicon wafers, there's something, the way they're manufactured is with what's called a it's a reticle. And the way to think about it is you shine X-rays through this mask, and the mask exposes a portion of a wafer. And GPUs are limited by how big is that reticle. And that's like, you can only make a GPU so big because that's what the lithography will allow in a current generation. And GPUs, made by many other different companies, have almost always had a version that was at that reticle limit. So think of it as GPUs are solving problems that are embarrassingly parallel. This is just an old expression. That means that pixels scale very evenly. AI scales very nicely. Scientific computing scales because you can do data parallelism. And that means if you can build really big GPUs, you can use it very effectively. That's not the case all the time for CPUs. CPUs generally work on more serialized threads. You can have multiple threads, but it's very hard to imagine when you're doing a CPU task to have, say, 10,000 threads. Whereas on a GPU, you can easily have 10,000 threads of work because you're operating on different data, and each data is represented as a thread.
Great insight.
Yep.
Thank you. Good
Yep.
stuff.
So actually, Tom's last comment was kind of a perfect segue to one of the first questions that I was going to ask. So you were talking about a couple, how much you guys have learned on this one and are working on Battlemage internally. Could you just give some insight to perhaps the less savvy folks watching, how much is gleaned and learned from a first gen chip, especially on a new endeavor like this for Intel, and how those learnings sort of affect the development down the line?
Yeah. The biggest, first of all, I want to make sure I was clear before. This is not really our first gen. We've been working on GPUs for 20 years, and we are the largest GPU manufacturer in the world. So I know that's all true, but what's really dramatically different is the balance of the GPU. A discrete GPU has like orders of magnitude more computing power than an integrated GPU today. And that means that the software layer, like how much work does the driver do? How much work does the CPU do compared to what the GPU does? It's dramatically different. Again, orders of magnitude. And what we've learned is that tuning for integrated, which basically says my GPU is going to take forever compared to my CPU, that's totally different on a discrete card. The GPU is going to be very short, and sometimes you're going to be limited by what your CPU is doing. So we need to learn that muscle and build that technology that's going to actually optimize a lot more on the CPU side, so that these big GPUs that we're now building are untethered. On the positive side, we've built a lot of infrastructure to do this. And so looking at things like micro benchmarks where we analyze the performance of our GPU, we have a very good engine, right? The engine is punches far above its weight. If you're just going to do scientific computing, or if you're going to do some kind of not CPU heavy gaming, you're going to see great results. And that's why DX12 tends to run better than DX11 and DX9, which are a little bit more thicker CPU loads for a typical frame. But we can also demonstrate to people that we are, in fact, getting better over time. We're doing a better job of unleashing the power that's in this Arc GPU. But nobody wants to hear promises from us. So what we're going to do, and I've said this publicly several times, is we're going to give people an amazing value today. And when we launch, you're going to be going like, wow, that's pretty damn good deal. And the basic premise is that we're not going to ask anybody to believe us, really. We're going to deliver on our promise of good perf per dollar right out of the get-go across DX12, DX11, and Vulkan, and DX9. That's our plan.
Sounds
like a plan.
Yeah, that's our plan. Yeah.
I'm going to pop a question up on the screen because it's related to what Tap was just saying. Not exactly related, but I figure this is one I don't want to slide by. So we have Yassine asking, what can first gen Intel Arc buyers expect in terms of driver improvements and support moving forward? I'm afraid Intel would try to move as fast as possible and target future architectures.
That's an excellent question, Marco. Thanks for bringing that up. I would say we are still in the high return part of the optimization curve. And what that means is that if we spend some more effort on the driver, we're going to see some significant returns. But it's going to take time. But I would expect that we're going to be moving quicker on performance improvements than, say, our competition does, who've already tuned this driver for 20 years, right? So when we launch, there will still be headroom left in the GPU that we intend to unlock on Arc. It's not like Arc is here for a week and then we're done. Arc is going to be around for a while, and we're going to continue to improve that architecture. And Alchemist, which is our first generation of Arc, is going to be around for a while. So we're going to continue to improve that with software updates. Interesting question, though, because I feel like it's a little soft, this answer. You'd rather see, like, give me an example of how this is going to get faster. And so actually Raja and I are sitting down talking through how do we help people understand this a little bit better. And I will probably have some content to answer that more succinctly, like show you, here's an example where something is being underutilized, and this is what we expect it to be like when we get done.
Very cool.
Sounds good. We have a whole bunch of questions on resizable bar and on older systems. So I'm going to kind of combine two questions. We have one viewer that's been asking how these Arc GPUs will behave in, say, 6th gen or older platforms that, say, maybe don't have resizable bar. Let's consider that part one. And now we have Window Scratcher asking, can Tom say anything about performance on non-ReBAR systems, especially the initial frame time issues? Also, will optimization bug fixes for non-ReBAR systems be on the roadmap for the driver people?
Okay, that's again great question so far, Marcus. So thank you. The ReBAR thing is a little unfortunate, honestly, because I think had we really understood the impact of this architectural choice, say 3 years ago, we probably would have done something different. Because nobody wants to have this sensitivity that requires ReBAR, but we do. And we made some choices about getting maybe a more optimized burst transaction, which had the converse effect of requiring it over time. So I would not recommend Arc on a system that does not have ReBAR support because the performance losses can be large, right? I've seen some that are like 30, 40% on some games and some resolutions. That's a high number. It's not usually that large, but I would hate to have a gamer be disappointed with Arc because they didn't understand, hey, you need a ReBAR system. And that means most modern systems, everything from Intel over the last, I think, 5 years supports a resizable bar, and same for AMD. It's a PCI Express optional feature that can be enabled in your SBIOS. We actually have a warning now on our driver and in our installer that says, hey, you need to get ReBAR turned on, buddy. And if you don't turn it on, you're going to be disappointed.
Got it.
But that's the most I guess that's the most honest and pessimistic way to view this. The other thing that I will mention is that there are things that we can do in the driver to make us less sensitive, right? You can kind of look at this type of transaction is causing our memory controller to kind of slow down. So let's figure out if we can do something in software to not do that transaction. But I would say that's a longer term thing. And again, I would not expect, I think we will get better, but I don't want you to buy Arc if you don't have ReBAR support.
Gotcha. Now I'm going to this one scrolled past, so I'm not going to get the exact question answered properly. What if someone has, an older rig that they're using for an HTPC and they just want to use your media engine? The card's actually going to install and work on an older platform.
Absolutely.
Yeah, no limitation. Just getting final confirmation.
Yeah, there's no platform incompatibility that I'm aware of. And really, we're just trying to be overly cautious, basically. We want everybody who buys an Arc GPU or an Alchemist GPU to just walk away going, this has been the best experience of my gaming life. And I kind of sadly have to say that's not going to happen if you have a much older platform that doesn't support resizable bar. Got
it. Dave, I feel like I have been monopolizing. Do you want to toss a couple over to Tap?
Yeah, no, that's fine. I don't mind you driving the bus. That's for sure. You do a good job of it.
Excellent job of that. Excellent.
Yeah. Go ahead. Maybe, what we should do actually, before we dive in a little bit more into the weeds, maybe we should start real quick with a quick high level, because I know Tom's got some slides here.
I do.
Of the family, just to give folks a quick snapshot who might not be familiar.
Sure.
Although a bunch of folks probably are, but yeah, let's pop that up on the screen real quick.
Yeah, go ahead.
Yeah, the little dog and pony, if you will. Yeah.
Sure. Well, what we're about to launch is our Arc 7 series. We've actually already launched the Arc A380, which is our entry level. It's built on 8 Xe cores, which is our smallest die. Its code name is DG2-128. And you can think of this as a more modest GPU. It's 75 watts TDP, and it has 6 gigs of memory. Now, as you go up our stack, you'll get to the Arc 7 series, which is what's coming up. And that will come in 3 flavors. There's an Arc A750, which is 28 Xe cores. There's an A770, which is 32 Xe cores with 8 gigabytes of memory. And then there's also an A770 with 16 gigabytes of memory. And they have slightly different memory bandwidths, but they're both at 225 watts. The secret encoder ring is very similar to what we do with CPUs. So there's an Arc 7, an Arc 5, and an Arc 3. Arc 7 is always going to be our top of the line. And the A in the A770 is our first generation. So A7 means the A generation, 7 class. When we get to Battlemage, it'll be B7. And then Celestial will be C7. And I don't know if there's there's a D, which is Druid D7, right? Now, I've been asking for ideas about E and F. So if in the chat, people want to give me E and F ideas for code names, We need some. And
there you go.
And as you go down the stack, you'll get to the last 2 digits. So 70 is our high end. Then there'll be a 50 and a 30 as you kind of fall down the stack. The numbers are meant to be sort of performance ordinal within a segment.
A for Alchemist. Makes sense.
A for Alchemist, B for Battlemage, C for Celestial. It's sort of similar to, I guess, 1080, 2080, 3080, right? The 10 for us is a letter.
Keep it simple, stupid, and folks will remember. That's good.
You know, if people are familiar with Intel's numbering, you know that this is shockingly simple for Intel. I'm very happy that we landed here. You know.
Agreed. Yes, logical, quite logical. Can you talk? So we see those specs. Assumption is they're based on what folks would call stock boards or Founders Edition, for lack of better words, Intel boards, Intel branded boards. What about can you give us any G2 on partner boards? Clock simile?
Well, I don't know if I have a deck on clocks, but let me tell you about what's going on there. On a clock, we have defined what's called a graphics clock. And I think there is just a brand new video that's going up on arc.intel.com today that talks about how we do our clocks and how we do overclocking. So if you guys haven't seen it, go click on that. But the way we do it is we look at distributions of clocks and across our entire bin of parts. And then we take a typical workload in a typical chassis and we run it and we see, hey, what clocks are we getting? And that's a distribution. And we're going to take the middle of it, and that's going to be our spec. So our stock SKUs, including our limited edition that we're building ourselves, are all going to have the same spec for the same device. So A770, I'm not sure. I think it's around 2 gigahertz, but we have to go check it. Don't quote me on that. It's around 2 gigahertz. And effectively, board partners have the ability to have faster SKUs, and they'll communicate that by having higher clocks for their graphics clock. And I'm not going to be able to announce any board partners because obviously that's up to the board partner to do their own announcements. But I'm pretty excited, and I think we're going to have relatively good, support across the ecosystem.
Nice. So partner boards or third-party boards could have higher end clocks, different designs as well.
Sure. I mean, just like you're used to seeing in the other board partners and ecosystem partners, we are very open, right? And by the way, if you're a board partner out there and you're not working with Intel, give me a call. We'd love to work with you. That's a little plug. Pick up the phone, give me a call.
And bring your special sauce, right?
Bring your special sauce, because we are, Intel's got a long history of working with most companies in Taiwan. Obviously, we are a major motherboard technology supplier. So it turns out that most of the guys that make motherboards are customers of Intel, and most of the guys who make motherboards also make GPUs. So there's a nice, we know these guys.
Yeah, I would think so. Very good. Yep. All right, Marco, what else we got?
I
see one from Steez that's interesting, but I don't know if that's a little early for that one.
I saw that scroll by. We're definitely going to have to get Steez is one of our premier viewers, so we're going to have to definitely feature him. So I just saw something. So some of the guys in the chat are asking about, and this may not be true for Intel's boards, maybe it is for partner boards. Will there be features like zero fan modes where the fans stop on some cards and they're silent when they're idle? Anything you can speak on regarding temps you've seen on the GPU or power or anything like that?
Sure. Well, we have a spec of around 225 watts for the current high-end GPUs. And we have a very efficient thermal solution on our Intel branded cards, which we call limited edition. So you're going to see relatively low temperatures. Typical gaming, I would expect the temperatures on the GPU to be between sort of 65 up to 80 degrees C. I think we set our temperature limit at 90, and effectively you can control that in our overclocking software to kind of set whatever temperature you're comfortable with. But we have a very efficient thermal, and effectively it's over-designed on our limited edition boards. So you can overclock it, you can kind of turn up the fans, and you're going to get quiet, but high performance thermals. We say right now with the fan, it's slightly louder than a whisper running at typical RPM.
Nice.
Got it.
Yeah.
Very cool.
Slightly
so you guys have done a ton of videos so far. You've done, hardware specs explained, real-time ray tracing, XeSS, all that good stuff, and you've already revealed tons of information. So if you're looking for a lot of Arc info after you're done watching us chat with Tap, make sure you check out the Intel Arc blog, because Intel really has revealed a ton of information. But let's nitpick and dig a little bit further.
Sure.
So you guys showed ray tracing in action, and I don't think you've perhaps you have, and I didn't remember the charts, may not have shown ray tracing performance in many titles. If you can't talk about ray tracing performance specifically, can you talk about the performance hit? Is it similar on Arc versus competing platforms when you enable ray tracing in a game?
Let me share one slide, because I think I did actually give out some performance information on this. Let me pull it up here. So let's go ahead and show this slide. I will come here. There you go. Beauty. So this is our disclosed information on A770 versus 3060 ray tracing. And what you can see is that on these titles, I guess there's 10 or 15 here. This is running their ultra mode at 1080p, and you can see that we will be beating 3060 on delivered performance. Another way to think about it is obviously XeSS works with ray tracing, and you're going to get huge uplifts when you turn on XeSS and ray tracing. So I'm pretty excited about both of these technologies. And last thing I want to show you is over here. I think I have one more perf chart for just kind of non-normalized ray tracing performance. So think of it as if you're looking at Shadow of the Tomb Raiders, turn ray tracing on A770, and you're going to get something like 78, 80 frames a second. You can see it's really kind of some wins, some losses versus 3060, but overall our performance is great. And I will add one more thing. Because of our architecture for ray tracing, you'll see our performance drop is significantly less than NVIDIA. And I don't know if I have a slide on that. I don't, darn. So this is our raw performance. This is our normalized performance. And I think I will talk about XeSS. And then I think this is the normalized performance of XeSS. Lastly, this is unlocking higher performance with XeSS balance mode. So I would say all of it is out there. We've got videos on both the hardware for ray tracing and the impact of this thing that I call a BVH cache and our thread sorting unit that really makes our implementation of ray tracing kind of deliver real performance better than our competition.
BVH cache, that's in the way back of my memory banks. BVH.
Yes.
Give us the acronym.
Okay, I got a picture that will help explain it. Let me get to that.
I heard that a long time ago.
Okay. So here you go. Take a look at this chart right here. Okay. Now, with the first picture on the left, it's showing you what my artistic rendition of rasterization is, which is traditional 3D rendering. And what you kind of do is you have a 3D model that's out there in your computer memory. It's just, a collection of vertices that are just data points, right? Just X, Y, Z coordinates in some three-dimensional space. And through a matrix multiplication, you can actually flatten all that geometry out and squeeze it onto what looks like a two-dimensional surface, which is a model of your screen. And if you do that, each pixel, each coordinate on that flat space, if you color it with a complex program, you can generate an image. That's how rasterization works. It projects, it kind of squishes all the geometry onto a flat plane and then colorizes each of the points based on a complex program that's the same for every pixel. Did you guys know that? You actually, when you're generating an image, you run mostly the same exact computations on every pixel. And then depending on what geometry is kind of covered by that pixel and like the angles that are expressed, everything runs the same computation. It's pretty cool. Mm-hmm. Now, ray tracing is very different. To figure out the color of a pixel, what you do is you sort of project a line from the camera. This is all imaginary, right? You're projecting a line from the camera through this grid, and you're going to try to find the geometry that it hits. Now, that process of ray casting is what ray tracing is all about. Instead of projecting the geometry to a two-dimensional surface, you're going to look in three-dimensional space. And if you find the triangle, you can try to figure out, well, what is the light source that's illuminating that particular spot? It's kind of a very different way to do the same thing. So the problem you have is, how do I find these triangles? Because there's millions and hundreds of millions of triangles in any particular scene. How do I know which one's the right one? And that's what a BVH is all about. So the idea is pretty simple. Instead of just searching every triangle, one way to go is the naive approach would be, for every ray that I cast, I have an angle and an origin. So I'm gonna run some math to figure out, does any triangle hit this ray? And then once you figure out, did a triangle hit this ray, you can find the one that's closest, and that's your answer, right? It's the closest ray, the closest triangle that got hit by a ray. So you can imagine how hard that would be to do for lots of rays in a big complex geometry scene. So what we do instead is we draw boxes around everything. So imagine, and I unfortunately I don't have it in this deck, but imagine that I drew boxes around these objects. And then I would draw another box within that box, and you get smaller and smaller and smaller boxes. And basically you search for the box first. So instead of looking for all triangles, you're going to look for boxes. And once you get down to these small boxes, you keep track of which triangles are inside that small box. So that box idea is called a bounded volume hierarchy. And BVH is the acronym for that bounded volume hierarchy. And the process of searching that hierarchy is much, much, much faster than searching all triangles. And that's what the cache is for. As you're casting many, many rays, if you can remember the results of that casting, you can save them. And it's very cool. Oh, you got a good picture. You got the movie. Nice.
Yeah.
So this is showing
Chris
you
is
that,
good.
I deliver.
Yeah, very impressive. So this is showing you a clip from our movie where it kind of shows you, hey, this is how we drew the boxes around that bunny. That's called BVH building, and it's run in our driver. It looks at every scene and it says, based on all the motion, where should I draw these boxes? And hopefully you don't have to redraw them on static objects. But if it's a dynamic object, you're gonna have to keep recalculating these boxes. But once you have these boxes, we built hardware inside of our GPU to really quickly look through all these boxes and find the end leaf. And then we build extra hardware to say, once we know the triangles, let's quickly figure out if they hit the rays. So that's called ray triangle intersection logic and box ray intersection logic. We have both of those.
And fat caches to keep it in memory resident nearby.
Exactly.
So
and if you guys are interested to take a look at the video like he's shown here, it's pretty comprehensive.
Cool. So that raises a question. I know nobody wants super proprietary stuff in games, but since you guys have a somewhat different ray tracing architecture in your GPUs, are there things game developers could do to, say, further optimize ray tracing on Arc that's perhaps not possible on current competitive architectures?
I think you probably could, but the truth is that we've built this architecture to work well on all games. And it's meant to be software invisible. The idea is that, hey, we've got one thing that's all about, let's make ray tracing work really well with lots of different materials, which is a common problem. Ray tracing kind of gets inefficient if you hit triangles that are all different materials because of some GPU architecture stuff. So we added what's called a thread sorting unit that makes that particular problem run a lot better. And then this BVH cache is just another acceleration structure that works with every different scene effectively.
Gotcha. And I know this super technical stuff. Some people's eyes are glazing over, but we have to ask this. So we have Ian in the chat, and he's asking, are BVH boxes calculated once in total or once per frame? Where is that BVH tree held in memory? CPU, GPU cache? How many trees can you keep in memory at once? That's a lot. So
that is another great potato. Is this Tech Potato who's doing
that?
This?
Is Ian, the Ian Cuttress,
Ian,
one and only.
Ian Cuttress.
Oh my gosh!
Good to see you, Ian.
So Ian, welcome. Are you? Let me know if you're going to come to Innovation. I'd love to say hi. So the answer is BVHs are just a data structure, and they're held in GPU memory, right? And so think of it as you create this sort of like hierarchical tree of boxes, and there's one tree for the entire scene, right? There's a root, and everything is covered by some box. And you would normally draw that once, and you would never need to draw it again, except scenes change. So as geometry changes and moves around, or lighting moves around, anything like that, you need to recalculate the BVH structures. But the rate that you recalculate and how much that you recalculate, it's got all kinds of optimizations, right? So you can say, don't recalculate static objects as one example. Don't recalculate dynamic objects unless they move significantly, right? Because you're kind of trying to figure out what's the right balance of accuracy versus performance. So BVH manipulation and recalculation it's an art and a science. Fortunately, we've got some really, really big brains working on it. And I feel like ours is pretty good. But this is also an area that's going to be continually changing. And DXR as the standard for sort of ray traversal APIs, I think that's going to continue to change, trying to unlock more and more optimizations strictly around BVH manipulation.
Nice.
That's a little bit long technical answer. And I suspect you could have multiple BVHs, but they're all kind of conceptually come together at some root. Now, there's a lot of questions about rebalancing these trees, right? Because you want the trees to be balanced so that you can effectively search it quickly. If you have one leg of the tree that's got a lot of boxes and another leg that's got a few, very inefficient, right? So there's a lot of BVH rebalancing and tree rebalancing and a whole bunch of magic stuff going on.
Magic stuff.
Yeah,
dig the magic stuff.
Cool. So we've had a whole bunch of questions fly by. I'm going to paraphrase a few and just kind of combine a few. Asking about, say, forcing DX9 on DX12, DX9 support, and touch on the reasons why Arc is optimized for DX12 and perhaps not quite as optimized for DX11. So can you sort of put all that together?
Yeah, I sure can. So let me start with a recap of what I kind of said when we started. Our engine is awesome. Like the hardware that we've got is, great at matrix manipulation, great at vector manipulation. It's got all the right resources for rasterization. So the hardware is a beautiful thing. Now, the problem we've got, and I'm not proud of it, but it's true, right? We have our software tuning is going to, it has to catch up to our hardware. And so that means that we've got places where we're less efficient than we want to be. And it's primarily, as I mentioned, because the balance between the CPU and the GPU has dramatically changed with discrete. So all the work that we've been doing to optimize, kind of our small GPUs that are taking too long, we're doing all kinds of things over the last 20 years to make them, try to shorten as much as we can on the GPU time. But doing that has kind of added stuff to the CPU time. So we have to kind of unroll all of that learning and do it slightly differently for discrete. Now that brings us to DX9 on 12. So one of the techniques to do this is to say, this DX9 thing, the driver path that we've got is huge because DX9 kind of pushed a lot of work into the driver and made the applications very simple. They're not really doing much management. There's very straightforward pipelines. It's basically built to make games easy, but it makes the driver more complicated. And what we did is we looked at it and said, well, we're going to keep working on this DX9 thing. We're never going to let DX9 go, but it's actually going to be quicker to do a mapping from DX9 to DX12 and make that mapping get more efficient over time. And we'll focus our efforts on the DX12 driver. So that's just a decision we made. And again, it's going to get better over time as that mapping layer gets more efficient. But in the short term, it allows us to really dig in on DX12. And so that's kind of where we're at. There's a limited number of DX9 titles, and of course they run, and they all run super fast. Like if you look at our DX9 performance, there's 170 frames per second, 190 frames per second. It's very, very fast. But compared to comp, who's got a more optimized DX9 driver, they're not great. So if you're a DX9 player, like you only play CSGO and you want to play it at 300 frames a second to get the lowest latency, don't buy Arc, right? Go ahead and get a different graphics card because that's not our strength. However, if you're playing modern titles and you want to turn up all the resolutions, you want to get great effects, you want to do ray tracing, you want to do AI, get Arc. Okay, so it's a bifurcated situation. So back to why is the go ahead. Okay.
No. So I want to finish your thought and I'll come back.
Okay. So it brings me full circle as to why is DX12 better than DX11, which is better than DX9. It's all about how much work can we get out of our driver layer into some place that manages better, like a game or a game engine. And DX12 does a very good job at parallelizing things and having multiple threads of things and multiple render passes, and that maps to a very thin software layer inside of our driver. DX11 is somewhere in the middle. It's got some more stuff that's going on in the driver. There's more work we have to do to kind of get some of the cruft that's built up over the years and optimize for more and more games. Every game is different. there's a million things you need to do in the driver to make a game run fast. And that's just going to be a labor of love for forever. And then we've got DX9, which is, our strategy on DX9 is really about mapping from DX9 to 12. And that mapping layer will get better over time as well.
Got it. I think that we need to clarify something.
Yes,
you
sir.
just said that there are certain scenarios where Arc is great and certain scenarios where perhaps it is not quite as great.
Right.
But that the reason for that may change with next gen Arc, correct?
Yes, for sure.
It's not don't buy any Arc ever. It's perhaps wait.
Alchemist.
Well, no, actually, no. I think Alchemist is going to be an amazing device for most gamers, right? So what I'm telling you is, if I'm a DX9 guy and I want to run CS:GO, I think there are probably going to be better solutions for that guy. But if you are playing modern games and you want to look at great effects, maybe you're playing Cyberpunk or you're playing, Death Stranding or any of the games that I love, I have an Arc and it's great. And I think it's going to be an incredible benefit to the world in general and to gamers who get an amazing per dollar for DX12. Because as I mentioned, we're not ignoring our total position in the market with regards to DX9 and DX12 and DX11. All of that's going to get factored into our pricing at launch, and effectively we're going to do pretty good.
And let's face it, if you're running a DX9 title, as you noted, you're pushing high frame rate anyways, because it's older legacy stuff that's not heavy workload.
Yep.
And so it's only that niche, perhaps that esports competitive gamer niche that wants to be 200 frames per second or an up.
Or more, right? Yeah. And I would say we're going to get better on that translation layer. And it may be that if you buy it now, it's going to get a lot better later, but I would not recommend that to anybody of mine who's like an esports guy sitting here playing DX9. I'd say, you know what, I'd wait a little bit. Let's let the enthusiast guys, the guys that are looking for all the eye candy and want to play great games, let them get the Arcs now. And then if you're a DX9 game guy, come a little later.
Gotcha. Makes sense.
Gotcha.
Right.
So I'm going to give you some practice for innovation, because Charlie Demerjon is probably going to ask this question.
Yeah.
It's not Charlie, but
go.
Charlie will probably ask.
Yes.
Can you give the current state of Linux support for Arc hardware?
We love Linux, and we're open with Linux. We do have an open driver for Linux, and I believe right now, there's a little bit of a chicken and egg thing with Linux that I don't know if anybody's figured out how to really solve it, but it takes a long time to get a driver into the Linux distributions. And you got to go through this sort of process to get it happen. I had somebody just explain it to me because I was befuddled by it. So some of these guys who are involved with the Linux kernel development and how source code goes into that process, it's very difficult. So we have a team of folks that does that for our driver, and they submit stuff all the time, and it goes through that process. And then we also do side releases, trying to enable these branches to be time to market. But we go on Linux as fast as we possibly can, and we are largely not gated by our work. We're gated by sort of the community nature of Linux.
Interesting question that just came in, actually, also from Ian. How many software engineers are working on Arc these days versus, say, a year or two ago? I don't know if you can quantify that. That might be a number that's not off the top of your head.
Yeah, I don't have that off the top of my head. It is growing. I mean, obviously, we have been in a massive bootstrapping process over the last 3 years, and the team has significantly grown. Unfortunately, Ian, I don't know the numbers off the top of my head. Maybe if you grab me or Lisa at Innovation, we'll get you a number.
Yes, after I get done grabbing you.
Yeah. Yes.
Innovation.
Yes.
No, I'm just kidding. Hey, so I did have some questions on the display side of things, and we know, your AV1 support, is industry first. What about the display engine itself? Is there anything differentiated about Arc versus competition on the display engine side of things?
I would say we've got an excellent display engine. We support all the major interface technologies, HDMI 2.0. I'm sorry, 2.1. I think. Let me pull it up. I think I've got a whole slide on this.
2.1's the
2.1, right?
one everybody's after now for high refresh rate, adaptive refresh rate on TVs. Yeah.
Here we go. So you can pull this up, and you'll see all the interfaces here. We've got DP 2.0 and HDMI 2.1 on the card. And we support all the major encoding interfaces: AV1, HEVC, H.264, and VP9. So it's really actually fantastic for all modern displays. We also, I don't say it on here, I think, but we also do support adaptive sync. So you'll get all that great variable refresh technology through the open standard, which is adaptive sync. That's what we're going to be all about. The good news is most monitors are adaptive sync now. There are some that are, using proprietary G-Sync, which I still love. I can't help it. But adaptive sync is the way to go for an open standard.
Very good. Very good. Excellent. Let's see, Marco. I'm scrolling up through the questions, see if we got any in the chat that we missed. There's a ton of them, man. Wow.
So I think we should actually ask for clarity on the HDMI 2.1. HDMI 2.1 for the 48 gigabits per second, board partners have to put a pecan on a chip on the board. Correct. And that may not be on all of them, right?
That's right. So in our board, the limited edition A770 and the limited edition A750, they will both have the pecan and they'll both have HDMI 2.1 support. On other boards, it's kind of up to the board partner how they want to, facilitate their displays.
Got it. Simple question came in the chat, and we've seen the A380 out in the wild. We've seen the A770. You guys have put it on display. What's the size of the card? They look really svelte, I might add.
Well, it's a 2-slot card. I think the length, I think it's about 10.5 inches, but I don't know. Hold on one second.
Okay. I wonder what he's grabbing.
He's getting a show and tell. Little show and tell. Chris, you're going to want to put him on the full view. There you go. Excellent. That a boy.
Hold on. Okay, got this.
This is funny.
Got my thing. Okay, it is.
You're so precise, Tom.
That is what, 6? That's 8. Right?
Oh my God, I want to make so many jokes.
That's 7, and yeah, it's got another 3, so that's like 10 inches. 10 inches.
Beautiful.
Which one's this? This is that's that's an A770.
A770.
Limited edition.
If you look close in the corner, it says Dave. Like that one's for me, right?
For Dave, yeah.
For me.
You know what? I do like it. Let me show it this. It's got these little. It's got sort of this flat matte black thing and a little chamfered edge. You can see again, Mark. I don't want to plug my own stuff, but we did just give a board breakdown of this thing on the website. You can take a look at it. We walk through the dual axial fins and we talk about this little diffuser right here, which is kind of special. It's got microstructures there that does a really good job of diffusing all the LEDs that go fully around it. There's actually an LED ring in here. So if you're into the LED thing, also this lights up and there's an LED thing here. So we got LEDs up the wazoo on this thing.
Yeah, but it seems elegant and understated. Like I do like how clean it is. It's lit, but I like how clean it is. Yeah.
I think I've talked to several people about it. I think it's a really sweet design, and it's very unusual to have this quality of board in the segment that we're talking about. So I can say it's going to be effectively a love letter to our initial customers, right? Because
a love letter.
It's a love letter. Hey guys, if you want to go with us, we want to give you this card. Okay, you want to hang out with Intel? There you go. It's a gift for you. Now, I've also said that we have 16 gigabytes of memory on the A770 on our version of the card. That's kind of crazy because there's very few people in the world that need a 16 gigabyte card. I know them though, and so we put 16 gigabytes on here, but we're not going to charge you anywhere near what that would cost. So think of it as, hey, come hang out with us.
You get more memory for your dollar too.
You do. You definitely do.
All right.
Yeah.
All right. And we can't talk pricing yet. You said you couldn't, right?
You can ask any question.
Can you talk pricing, Tom?
No, I can't talk pricing. I could, but it'd be the last time you'd see me with Intel. But I wish I could. I wish I could because I would be excited to talk about it with you.
Okay. All right. So but I think by deduction, if you're comparing a 770 to 3060 class performance, 3060 Ti or whatever in that range, it's going to be less.
Yes.
That's not saying too much.
Perfect.
Yeah, you named a couple different GPUs there and you were kind of vague about it, and I gave you a direct answer.
Exactly.
So,
All right.
I just want to make a
Very
quick
good.
comment. So if you put a question in earlier, it has already scrolled past us in the
Oh, yeah.
StreamYard interface.
Hit it
So
again.
if we
Yeah.
didn't get to something, go ahead and ask it again. But I want to ask a quick one. So there was a very cool video that hit today from Digital Foundry. You guys let him do some testing on Tomb Raider, XeSS versus DLSS.
Yeah.
We have a news post stuff summarizing that video if you're not a video guy on hot hardware, but can you provide some insight? Is that experience that was shown in Tomb Raider, can gamers expect a similar experience from other XeSS supported games in terms of the quality comparisons, performance improvements, etc.?
Absolutely. Very, very, very similar. I think I did give out a lot of performance data in our XeSS video, maybe 15, 20 titles. And the performance uplift is going to vary depending on the basic render rate. So if you have a slower title, meaning it's very, very heavy, you actually get a higher uplift from XeSS because it adds a little bit of time to the render for doing the XeSS. But the fact is you're going to render at a lower resolution when you're running XeSS, and that dramatically shortens the overall render time, which gives you much higher frame rates when you have a long render to start with. So I'm very excited about the tech, and that Richard did a great job, and so did Alex. We went over to Berlin and hung out with those guys for a day, and I've always appreciated all of their work. I know you guys have as well. They do the really detailed stuff, and I remember I met Richard years and years ago in London for the first time, and I brought over a thing I developed called FCAT. You guys remember FCAT?
Oh yeah,
I still have the whole setup right next to me.
Really? Yeah. So that's how I met him, and I've watched his stuff for years. He does a lot of console stuff, and I've just been super impressed. So shout out to Richard and Alex; they do great work. And the way I was like, I think I'm giving you this because I'm pretty confident, but you do you. And whatever happens, and I'll live with whatever results we're giving you. But I feel like the XeSS team, Vladimir and all the other guys in the team have done just a tremendous amount of work, and they've landed what I'm going to call a great product. And the truth is, it's kind of delivering the same experience as the second gen of everybody else's technology. So that's one that I feel like we're really in great shape on.
And in terms of image quality too, I should have clarified. I know you guys already released the perf data. Are those image quality comparisons? Do you expect to see those strong performance in XeSS in terms of image quality comparisons as well?
I mean, you'll see there are some scenes, and even in the review, they did talk about a few things that we want to improve. There was some flickering on some vegetation, obviously, and there was some moray in some water. So that's all that kind of stuff of, as we get more games, as we get more feedback, we're going to continue to improve our algorithms. And with AI, as you know, it's all about, hey, what data are you using to create your AI model? And we'll continue to improve that data set, and we'll continue to improve our model over time.
Yeah, I'm going to drop this one in the chat here. And really, I guess it's more of a critical mass kind of question. That was what was rumbling around in my head as well. How are we looking on game adoption to enable the feature? Where's that kind of state of the nation right now?
I will say, again, I don't want to toot our own horn here. I like to be kind of modest, but I think our DevRel and our Dev Tech team have done a great job. We have wide adoption for XeSS titles. I think I talked about roughly 20 titles in our video. Obviously, we've had more since then. And in terms of availability, what I'm saying is that we will make XeSS available when our GPUs launch. Now, it may be slightly earlier on some titles because we don't want to block our ISV partners from getting to market with their games. But the truth is that you can't really use XeSS until you get the GPU anyway. So I keep to saying that, hey, it's going to be roughly coincident, if not slightly ahead of when you get your GPUs.
Excellent. Good answer. Good.
Cool. So we have a couple of two really important questions that just popped in. First one, will the Arc cards, the limited edition cards, come with a sticker like your CPUs do?
I don't know.
I don't know. The bundle, the gimme bundle. Yeah.
I do not know that answer. Sorry, I don't know. But I can say it will, like this guy right here. You see this little thing right here?
Yep.
Yeah.
That is a little connector for the LED controller board that's in this thing. And that runs a connector down to your motherboard USB header. and that's how you control the USB. So that cable for sure is in the box. But
cool.
Yeah, don't know about the sticker though.
So you can coordinate your lighting with your
Yes.
motherboard LED software. Excellent.
You can set the colors of the LEDs to patterns, to blinky things, or you can actually set individually each LED. And I don't know what the number is, but there's I think there's like 80 LEDs or something stupid. It's LED heavy.
You are RGB'd, baby. Okay. Excellent.
Yep.
Excellent.
So we're getting close to the bottom of the half hour here. So we have to ask about availability. What can you say about potential release and availability, not only for general public, but for the scavenger hunt people that have one card?
Oh, okay. So that's a great question. So I can say whatever I want, but I shouldn't say anything.
Gotcha.
I can say what I will say about the scavenger hunt people is I really do appreciate them hanging out with us, right? Because that they won that scavenger hunt a long time ago, and that just gives you a hint of how hard getting this graphics card out has been. But we're not going to launch it until it is, until it is really ready. And so that's what's happening. We're making sure this card is going to deliver a great experience. And unfortunately, that means the scavenger hunt winners who won graphics cards have had to wait. Now, because it's been so long, we've actually reached out to those guys and said, hey, listen, we apologize. This is terrible. You shouldn't have to wait this long for a graphics card. We'll give you two choices. We'll either give you other compensation right now, and you can go off and do whatever you want. Or if you hang out with us, we'll make it good in the end. You'll get your GPU. So we did give the scavenger hunt winners an early exit if that's what they preferred.
Got it. Got it.
Okey-doke.
Interesting question. Looks like the folks from Video Cards are in the chat. Can Arc mine Ethereum? Why not?
Is that even a thing? Is that even a thing anymore? Didn't Ethereum just move to a proof of stake? I think I'm not sure.
It tried to, but
was it today?
Did it today?
Is it today? I think, right?
I think it is today,
We
right?
put an article.
Yeah.
Oh, is it? Oh, okay.
Did it happen? Is it all
Before?
behind us?
Yeah. I don't know. I don't track that real time.
Well, to answer the question truthfully, I don't expect it to be a great miner. I hope it's not a great miner, but it might. I honestly have not even looked at it. To tell you the truth, I care so little about it.
I gotta say, Dave just triggered me with that Video Cards logo on the stream. How many articles have I written that you guys have scooped me on with the leaks? Okay, sorry.
And they love it. They're probably laughing.
Oh yeah, they're laughing at me right now, I'm sure.
Hey, can I share one factoid with you guys?
You can share 10 factoids.
Hot off the press.
Oh,
I was doing. I just posted that overclocking video. Ryan and I were in Santa Clara playing with an Arc. I think it was actually this guy, and we didn't do any sorting. We didn't like go through the manufacturing guys and say, find me a cherry card, because we could have said, go find me a cherry card, and they would have run a bunch of tests, and I would have said, this card is the one, right? But we didn't do it, and we just pulled it out of our inventory. Guess what clock we got?
Talk to me.
3 gigahertz. No, I'm
2.7 gigahertz.
Whoa!
Nice.
And that's just on air, right? We're just playing with it. We did some curve modification. We did some over voltaging. We added a little bit of power. Boom, 2.7 gigahertz running Hitman 3. So that's in the video.
And
check it out.
No visual anomalies, stable,
No,
all that
rock
good
solid.
stuff.
Well, I don't want to say rock solid, because at 2.7 gigahertz, I almost put it in the bloopers because I don't want to set expectations at 2.7 gigahertz, which is stupid because now I'm doing that. But here we are. But it was super fun, and I was excited to see it. That's my first time. I mean, I've been with Vince doing like liquid nitrogen overclocking. He's a kingpin. He's like a world record guy. And I've been with all those folks. And it's crazy what they do, or what they used to do, to get to 2.7 and beyond. Now, I don't know what's going to happen with this. I'm actually thinking about seeding the card out to a couple people just to see what they can do.
Well, you should give it to Vince because he's Italian. So
I love Vince.
Well, and to Marco, because
if Vince wants it, he knows my number. Vince, if you're watching and you want the card after launch, give me a call.
So there two quick questions, and I know you got to run. Can you comment on what power was at 2.7, or is that off limits?
It was around 228 watts, roughly. But check out the video. I think it's in there.
What was the temp? Would you comment on the temp?
I think it was around 80C, but again, I don't hold me to that. I would encourage you to, take a look in the video. It's all in there.
Okay. Okay.
Is there any insight you could give? There was a couple of questions earlier too on the XMX engines, and if scrolled past, I'm sorry. And any comment on machine learning and AI performance that you could talk about?
I don't have a benchmark to share, but I can say that we built some big matrix engines into the GPU itself. We have a matrix engine with each Xe core, and effectively that thing runs 16 times as fast as a traditional Mac instruction. So for inference, which is the fundamental operation of what AI is, it's running this thing called inferences. Inferences basically a gigantic parallel multiply of 8-bit integers, multiply just everything all at once, and then do a single add. And that's like what AI does, believe it or not. And then it does a nonlinear transform after that. And that's really what the systolic array does. It does these multiply, accumulates, all in parallel, all across our GPU all at the same time. So it's basically as fast as we can get it to go with existing transistor limits.
Very cool.
All right.
Hopefully that provides some insight for the people that asked the questions that I missed.
AI is going to be pretty good. I mean, the fact is that AI is changing everything. Right now, we're applying AI to graphics, and that's what XeSS is. And it uses our XMX block, which is that giant systolic array, and that's why we get great uplift. We can run our inference very quick. And that means that we can get these frames generated really quick. But I'm excited to see what else happens with AI. Whoops. Hold on one second.
Well, he dropped the 770.
There we go. Lost my thing. Sorry about that. I was just saying I'm excited to see what else happens with AI on the client. And I think that we're really just at the beginning of all that.
Yeah. Smart folks will be playing around with those cards in lots of different ways for sure.
I hope so.
That's good stuff. We thought you dropped the A770 there. We were like, is this an A770 drop test? Or
No. She's fine. Actually, I haven't really thought of it. Is it a male or a female?
Well, I think we always refer to these things as she, I guess. It's kind of like, the captain that refers to the boat. Yeah.
You're going to get us demonetized on this platform talking about this stuff.
No,
let's move on.
A hat tip to the fairer sex, let's be honest. So I think that probably brings us to a wrap, right? I think we're gonna get the hook from your handlers or whatever.
My minders.
Yeah. Did we miss anything, Tom? Did we miss anything that you were dying to get out?
You guys are great. Well, one thing I do want to say is I want to thank everybody who's been involved with this GPU journey. It's been a bit of a longer trip than we expected, but the engineers have persevered. And I got to say, I don't think people, I mean, I know you guys do, but I don't think everybody really appreciates the amount of difficulty of this. We're like the last people that could possibly do this. It's that hard. And getting the chip done, getting the driver done, and now bringing it to market, it's just so exciting for me. And I know that the engineers that have worked on this for 3 years are equally excited. So it's a big time for us. I'm just dying to be, across the goal line.
There you go. Coming soon. You're getting there. You're inside the 5 probably, right?
Oh man.
All right. Well, Tom Tap Petersen, thank you so much for joining us today. It's been a pleasure as always.
Thank you very much. It's great to see you.
Yes, you as well. And we are waiting with bated breath for those cards to arrive to market so that we can get our grubby geek hands on them. You're gonna seed us with a couple of those, right?
Absolutely.
Of course.
You will definitely get them. You kidding me?
We'll be torturing your marketing.
Marco's getting it?
Oh, both of us. We need
both of you guys. We are sending
setups.
2. We are sending 2. So talk to Nick.
Nick is back there squirming.
Yeah, I know exactly.
I'll make it. Is Nick on? Can he talk?
Yeah, I'm here.
Nick, hey, are we sending them? We are sending them cards, right?
Now we are.
Yeah, we knew that.
Yeah,
all right. Well, hey, Tom, thanks again. It was great to see you. Tom Petersen from Intel with the Arc Graphics
Marco,
division.
take care.
You
Good to see you, brother.
Appreciate it.
You have a wonderful evening, and folks, stay tuned to Hot Hardware, where you'll have coverage on everything Intel Arc in the days ahead. HotHardware.com, where you can find us on the web, Twitter.com/Hot Hardware, YouTube.com/Hot Hardware, Facebook. We're everywhere. Hit thumbs up, subscribe, please, so you get notified when we go live again with fantastic people like Tom Petersen. So, and with that, we will bid you adieu, and thanks so much for stopping by.